This is my fifth video in my module on quadratic functions, and in this one we're not going to be graphing. What we're going to be doing is taking quadratic functions that are maybe in different forms and placing them into standard form. So to write something in standard form, recall standard form is anything, if it's quadratic, of the form y or f of x equals ax squared plus bx plus c. And you'll notice here I've got a couple of functions that are defined, the first one here being an intercept form, and the second one being in what we refer to as vertex form. And maybe I want to write these in standard form for a very good reason. It's very, very standard. So here's the deal. In order to do this, we're going to have to use a method that we call FOIL. Okay, so FOIL, something you've maybe heard of before. We say FOIL, F-O-I-L. As a matter of fact, I'm going to write these longitudinally. We say F-O-I-L, and what this stands for is first terms, okay, outside terms, outside, inside, and last. Okay, so this being said, what we're referring to really is a set of binomials here. So if I were to take like x plus 3 times, say, x plus 2, how would we multiply these? Fact is, we'd start with the first two terms in each set of parentheses. So we'd say x times x, and it's good to write the little rainbow there. X times x is x squared, by the way. So we've got our first outside. That refers to the x in the front here and this 2 in the back here. So we say x times 2, and that's positive, so we say positive 2x. Now our inside two terms, that would be our 3 here and our x here, we'd say now 3 times x, so that'd be plus 3x. And then last but not least, the last two terms here, the 3 and the 2, if we multiply those, we get 6. So this is typically simplifiable, not all the time, but we say x squared plus 2x plus 3x, that's 5 total x's. We say plus 5x plus 6. And a good thing to kind of look forward to here is notice that the 3 and the 2 up here in our parentheses, they multiplied out to be this last term and they added up to be the middle term. But that's neither here nor there. Let's go ahead and talk about how we're going to use this FOIL method to now write these things in standard form. So taking a look at this first example, I'm going to rewrite this. As a matter of fact, I'm going to rewrite it like this. -1 times x plus 4 times x minus 9. So I see a lot of mistakes when I give problems like this. But the fact is, this -1, what do you do? Do you take it times the first set of parentheses? Do you take it times both sets of parentheses? What do you do with it? Do you multiply? Do you FOIL these first two out first here, or that times that times that, and then do your -1? And the easiest way to do this is do your multiplication from left to right. So we're actually going to multiply these two things first. The important thing to note is, just as if I were taking three numbers multiplied together, like 3 times 4 times 5, I would not take the 3 times the 4 and the 3 times the 5. I would just take the 3 times the 4 and get 12, and then I would take my result there times 5, and I would get 60, okay? So the fact is, we're going to do our multiplication from left to right, and then just kind of collapse it down into what we get finally. So this means that our -1 here, we're going to rip it through this first set of parentheses. So when I take everything in the first set of parentheses times -1, you actually end up with this. -x minus 4, and we have our x minus 9. So now I want to say something about the way I've just written this. Fact is, we multiplied those first two terms together, the first two factors, the -1 and the x plus 4. This would be a mistake to write it this way, okay? We are not taking -x minus 4 times all of this. We're actually taking that entire first product, which was the product of these two things right here. So that means the whole thing. Have to have parentheses around it still, times this. So now we're going to use our FOIL method. Okay, well, that being said, we'd say -x times a positive x. Well, -1 times positive 1 is -1, and x times x is x squared. Now we'll do our outside. So we say -x times a -9. Well, -1 times -9 is a positive 9, and we have an x. Inside 2, we say -4 times a positive x is negative. So we say -4x's. And then -4 times a -9 is positive 36. So combining the terms that are like each other, we say -x squared, positive 9x's, but take 4 away, we'd say we have a total of 5 total x's plus 36 constants. Okay, so that is what it would look like if you had something in intercept form. You would start by multiplying the first two terms, your a and your first set of parentheses, and then take that result, the entire result, in parentheses, and FOIL it with your second or your third factor over here. Okay, so now I really want to talk about this vertex form 1 over here. We say y equals 3 times the quantity x minus 1 squared plus 8. The number one mistake that you'll see on this is the idea that people have that you know, we're used to distribution with numbers in front. Can we do this? Can we say this is x squared minus 1 1 squared and distribute an exponent. And this is entirely false. You may not distribute an exponent through a sum or a difference. And the reason why is this. Let's just simply consider, what does it mean to square a quantity or to square anything? And it means to take it times itself. Okay, so what I'm going to tell you is, if you want to get these right, and I'm sure you do, when in doubt, you write it out. Okay, so we're taking this thing squared. That means take it times itself. That means you need to rewrite this as x minus 1 times x minus 1 all of the time, unless you're very proficient with binomial expansion. So here's the deal. Just like in our last example, we're going to have to start by multiplying these first two things left to right. You know, it's order of operations here. So we'll go ahead and distribute our 3 through the first set of parentheses and rewrite what we have now. So we say in parentheses, 3 times x is 3x, and 3 times negative 1 is negative 3. All of that in parentheses times that second x minus 1, that plus 8. So now we're going to FOIL these things out. So we get this, y equals, well, 3x times x is 3x squared. 3x times negative 1 is negative 3x. Negative 3 times a positive x is also a negative 3x. And then negative 3 times a negative 1 is a positive 3. We're going to take all of that product. We're still going to add that 8 on at the end. Don't forget your 8. So now combining like terms, we have these two terms are like here. We'll put that in red. And then we have constant terms that are also like. So we're going to combine both sets of these, and we end up finally with a final result in standard form of 3x squared. Take away 6 total x's, and then adding on 11 total constants. And so now we have something that we wanted, which was something in standard form. So if the directions say write it out in standard form, it just means multiply everything out, and then, yeah, combine like terms. Cheers.